Okay. Oh. Come on. Did you meet Ruji lately?
Affected.
You want to sign one?
Yeah.
Sign it here. Oh, this one. Can we get started? Yeah. You can get started. 350, right? You can get started.
Yeah.
Okay, welcome. This is the DMM working group meeting. I'm Sri Gundavalli. And so today, the agenda for today, I think before we get started, a few things. So please look at the IPR policy. There are RFC references, 3978 and other documents. Please review them. And there is note well, this meeting is governed under a few IETF rules and regulations. You need to be familiar with these. Please review this material. And few other things. We need a note taker, please. Anybody volunteer? Note takers, please. Any volunteers? Dave, thank you so much. Truly appreciate it. Yeah. So Dave Allen will take the meeting minutes. Yes. Yeah. Yeah. On the Ether. Thank you. Okay. And one more. Anybody else? Carlos, meeting notes. Note taker. Yeah. Anybody else? All right. So few updates. These are the working group documents. The first one is the user plane protocol and architecture analysis on 3GPP 5G system. Yes.
Shunsuke Homa from NTT. I'm a co-author of the 5G user plane analysis draft. So as you may know, 3GPP already started release 16 in SF2, and CT groups will finish the release 16 on the next March. So we, the authors, would like to decide the finish of the goal of this work. So
Right.
we will continue to update the draft within release 16, and after that, we would like to proceed it to the next step. We believe that this draft will be help for many IETFers to understand 5G architecture and user plane protocol. So if possible, we would like to request a working group last call for the information draft. I'd like to know your opinion. Thank you
Yeah,
very much.
sure. I think Suresh is also there. I'll state my opinion. So, yeah, I understand the status of that work in 3GPP for release 16, right? So I think we need to look beyond. I think the way I look at it is like, what we can do in the release 17 time frame and all of that. That's my personal view. I'm not talking on behalf of the working group, but Suresh is also there. Let's hear what he thinks with respect to.
Yeah, so discussion responsibility, right? So I think it requires some kind of review from the working group, right? And one thing we can do to speed up the process is we can send an LS, right? Like if the working group decides to send a liaison statement, we can write one and send it, right? But I cannot see any way this will be done by March, right, of 2020, right? Like, so because there's reviews from the working group, complete the working group last call, okay? Then it needs to come to me, get the directorate reviews, go to IETF last call, and the holidays, Christmas holidays come in between, right? So it's very unlikely that this is going to be done before then. Okay, we can do as fast as we can, but I think if you want to inform the 3GPP officially, I think the best way is a liaison statement.
But one comment before I give it to Satoru-san. So at least the dependencies from the spring, those are in a good shape, right? At least compared to previous IETF 105, now we're in a better shape.
Yeah.
Right. Okay. Satoru.
Yes, I think the Shunsuke-san's intention is kind of the analysis work based on the end of the state of the end of the March, not to complete all of this procedure for the IETF procedure. So this time we want to put the milestone to finish the work based on the G16. If they need to think the further analysis based on the 17, that would be another chance to work.
Okay, no worries, that's fine. So if it's like working group process, yeah, it makes sense. You can get it done.
And if you need following release 16, release 17, so we can start as a new work.
Okay.
Now let's go over the status of different working group documents, right? We talked about the user plane protocol. I don't believe we have a presentation slot for this, right? For this one, right? The next one is the segment routing for IPv6 for mobile user plane. I think there's a good amount of work went in, but any update on this? You want to give Pablo or you? There's a presentation slot. Okay, maybe we'll review that during your presentation slot. Then the FPC document. I think this is really a bizarre situation. It's an incredible amount of work went into this FPC document, but overnight it's like a turning off the lights, right? Complete silence on this FPC stuff, right? So I think the documents have expired, and the FPC work was on Charlie's request, and essentially we split that up into the Yang part. The Yang portion was separated out. Right, but I think we need a way forward for this. I think you will give an update later for a 5 minutes update, or
yes, I try to summarize the update regarding the FPC at the end of this meeting. So let's discuss on how to proceed or the fate of the document.
Whatever. Yeah, I think definitely. I think we need to one way or the other close it. That's. The distributed. These are the documents that I've passed working group last call. I think one. I know Suresh is going towards the mic. I think the chair, the Shepherd note needs to be rewritten. Right?
Yeah.
I think,
so for both of these, actually, the first two, like the Shepherd write-up is very bad. It didn't summarize pretty much anything about the working group process, and I really cannot put this in front of the IESG in that state. So whenever one of you get a chance to update the write-up, I'll try to schedule it on a daily chat. Okay. And Carlos has been really good catching up with the directorate reviews and addressing them. So I think it's good. And the last one, it's RFC.
Right.
Okay. So it's like one of the.
Queue. I don't know if it.
No, it has a number.
It has number. Sure.
It has a number, yeah. So it's pretty much done deal, right? And it's one of the first ones with the V3 format, the XML to RFC V3 format. Yeah.
Yeah, so I'll talk to Devang as well. He wrote the Shepherd notes on both the documents. I'll discuss with him and essentially.
It's just a little bit more detail, right? Like,
Yeah,
because it has nothing about the technical summary, because like
Yeah.
people who read the Shepherd write-up will not be
Right.
happy.
I agree. Absolutely. Yeah, I think on-demand mobility management draft, as Suresh said, it got the RFC number. It's in the still the publication queue, but it's a done deal. It's done. It's done. Yeah, practically it's done. Okay. Yeah, good stuff. Congrats to others on that one. And not yet. I think now we'll go to the individual work items. Right. I think the first presentation is from Pablo, I believe. Maybe end of the end of the document. Maybe let's okay, cool. Okay. So Pablo, if you can also tell the working group as what changed within the last revision, and there's a new revision, right? I believe.
Yes,
Yeah.
so there was a new revision.
You can still drive the slides.
Okay, so good afternoon, everyone. So I'm here to present the latest revision of draft IETF SRE6 mobile user plan. Since the last meeting, there have been two revisions. So the first revision was the revision 6. In revision 6, we have simply removed any text suggesting to do segment routing and their insertion, which was there in the draft, and there's an ongoing debate on 6 months. So just to progress this draft, we decided to remove it. And then the next, the second revision, which was revision 7, it's a more interesting one. So here, the first change is that we have added a drop-in mode. So the drop-in mode is a mode that we have been using throughout several demos, where we are just, which is actually this one, where we are just simply translating the GDP at the segment routing gateway. Thus, we are translating the overlay to SRV6 with some SLA and traffic engineering, and then we have another SR gateway to reach another UTF, which is still GDP. More changes that we also had in the revision 7. We did a lot of editorial updates, changes to the terminology, some changes to improve credibility and updated reference. And then the last important point is that we have removed the support for unstructured PDUs. So as you know, in 3GPP, there are defining PDUs as IPv4, IPv6, Ethernet, and unstructured. Due to some changes that we have had in SRV6, particularly in the encapsulation of Ethernet PDUs, now we can no longer support unstructured PDUs. This could be done, but we would need to allocate a new Internet Protocol number. At this point in time, the authors think that there is not a strong requirement from the operator community to support it. But we are open to your feedback, so it's really up to whatever you think. Then we also participated in the hackathon this year. We had a lot of progress. So finally, after several hackathons, we have finished the BBP implementation. So we have a full BBP implementation of all the code that is in this draft. We have submitted this code to the BBP repositories, and so in the next BBP release that will be in January 2020, all this code will be available to everyone. That said, we really want anyone to do more comments and review the draft. But given that the draft has been relatively stable, we believe that it's ready for working group.
Okay, thank you, Pablo. So from your point of view, it's pretty much in a great shape, right? All the changes, any dependencies, whatever went in the other groups are reflected into this document, right?
Yes. So the biggest dependency is the SRV6 network programming, where we are also proceeding with working group last fall.
Okay. So any questions, comments? So how many people have read the latest version of the document? Okay. Okay, we need a few more reviews, and maybe then from there we'll take it from there.
Okay. Great. Thank
Okay.
you.
Carlos, when I was your stream, I can do one review.
Okay, thank you. Thank you, Carlos. So this is a new topic. This is it's still a individual ID, right? User plane message encoding, that 00 version. Let's see. Yeah. Let's see. Yeah, I think if you can introduce the topic, what is it, why it's important, and then go to the presentation. Yeah.
So good afternoon. So this is the new draft for the user plane message encoding. Yeah, here's the motivation. So 3GPP user plane need to support the user plane message associated with the GPU tunnel. So in the case of the characteristic user plane, so these messages are also required when the user plane interact with the GPU. So SRH has a tag field definitions. So tag field has a capable to indicate a different property within the SID. And also SRH TLV has a capability to match the user plane messaging, has a capability to provide the metadata to the endpoint node. So this capability of the SRH should be leveraged to match the user plane message into SRH network. Sorry. So, and also in this approach, so there is no additional header or extension headers to carry the any user plane message. Yeah.
How to do that?
There should be a
Sticker.
Oh, it's good. So here is the GPU message format. So each user plane message is indicated with the message type. So for example, so echo request is using a 1 as a message type, and echo reply is using a 2 as a message type. Yeah, here is the segment header. So segment header has a tag field definition. So currently there is no defined usage of this tag field. So we are thinking to leverage the tag field to carry the message type for the mobile user plane message. So here is the encoding of the tag field. So we are using a 4-bit rightmost 4-bit to encode the user plane message. So B12 is for the end marker, and B1 is for the error indication, and B2 is for the error echo request, and B3 is the echo reply. And also, some of the user plane message requires some additional information elements. So these information elements can be encoded with the SRX TLV. So we are proposing the 5GS container TLV as a new SRX TLV. And also, this TLV can carry the multiple 3GPP IE TLVs. So here is the 3GPP TLV. So yeah, it's a sub TLV of the 3GS container TLV. So however, 3GPP IE TLV should be followed with the 3GPP specifications. So user plane message can be carried with the SRH. For this, in order to carry the user plane message over entire service network, so SR header must be sustained over inside of the SRV6 network. So, however, so if enabling the PSP, so SRH header is popped up at the parameter segment. So for this, in order to avoid this problem, so one solution is the PSP must not be used in the SRV6 network in order to carry the user plane message. Or if enabling the PSP, so another SRH should be added to carry the user plane message on top of the outer IPv6 header or SRS header. Yep. So for the next step, we would like to adapt this draft to the working group draft.
Okay. Uma.
Hi, my name is Uma from Future USA. I read the draft. What is the main use case? I didn't understand for this. Like, you want to remove GTP completely with SRv6. So some parts are removed with the current last call document, right? I think some part of the GTP with SRv6. This is a complete elimination of GTPU. Is it correct, or what is it, the main goal?
So in case of the dropping case, so GTP, let's say, for example, GTP 6D dropping. Yeah. So GTP 6D can terminate the GTPU tunnel. Okay. However, so GTP 6E need to regenerate the GTPU tunnel. So at that time, we have to keep the required information inside of the SRv6 network.
Okay. So I was just like, it's not written, but I was thinking, is there any use case you are thinking to send the message with the GTP encoded message right from the UE itself? Is there any use case, that kind of thing you are thinking, or?
This is not from the UE, right? This is between the network elements.
There's a possibility, right? With this, you have the real possibility. You extend all the way to the
I
UE.
think their goal, if I understood correctly, is to, all the path management and all of that stuff, they want to put it back. Right? Is that the driving goal? Yeah.
Okay.
Suresh.
Suresh Krishnan, just to answer Uma, the reason why you don't want to do that is the spectrum is very expensive, right? So you don't want to put in all the headers on the interface, right? That's why the GTP is starting from the base station towards the core network, not from the UE.
That's a great answer, actually. That's correct. But, I think that's the only SRv6, the only solution that's really all the way can go to the UE if you want it, right? There's no other solution. So, but yes, spectrum issue, I agree with you.
But it's a good point. I think, you can explore, identify the use case. So any other comments, questions, Alan? Dave?
Yes, just I think the information that gets carried on GTP, either things like the N marker, et cetera, they're only of significance to the Gnode B. Right. That stuff does not need to be extended to the UE. Right. So, and any stuff that does need to be extended to the UE is done over the PDCP layer.
Right. So with respect to currently, you have the path management, that N marker. N marker, it's not covered, right? Actually, in this, I didn't see any N marker yet.
Okay. So we covered the N marker. So, however, so we don't have a detailed definition of the 3GPP TLD.
Okay.
Should be followed to the.
Okay. So, but if you take the echo request, echo reply, GTP has number of options and all of that. How do you plan to carry all of those options as a TLV?
TLV.
Okay.
Using SRH TLV.
Okay. I think this is a logical extension to the earlier work. I don't see any problem. I think this addresses, rather completes the whole work. But we need more feedback from the working group and also, from the AD and, to make this part of this thing, right? I think our suggestion is engage with keep doing the work and essentially we can try to adopt the document or whatever. Thank you.
Thank you.
Any other questions? Oh, here, done. Yes, that's it. Thank you. Okay, how do I? Okay, next one is the transport network considerations. I think Uma. So this is not a working document; it's a proposal, and yeah.
Good afternoon, everybody. My name is Uma, and I'll be co-presenting with John, my colleague in wireless group. This topic is transport network aware mobility for 5G. Just looking.
I don't know this. Okay.
Maybe you need to flip the slides maybe for me.
If you know how to do it. Yeah, let's keep it simple. Yeah.
Okay, just a quick recap of this draft. This has been presented first in 2018, IETF 102.00 version. We just laid out the main problem and Strawman solution. Also, it's further updated and presented in IETF 103. And the major update happened in last IETF, where the original solution and set two approaches has been presented to put the framework. And also there were multiple options proposed to carry the NTNC ID proposed in the IP header. And way to put that NTNC ID, there was a lot of discussion happened and we got a lot of inputs, not only from here and also from the Peace Working Group and also offline discussion. So what we have done in this version is basically we unified the two approaches and finalized the path forward for progressing this draft. And also we narrowed down the options for carrying the NTNC ID. Next slide. Okay, just to, for the benefit of the people who are not there in the earlier, just to give the background and problems that is being addressed in this draft. We all know release 15.23.501.502 specify 5G architecture and various SSC modes, new mobility modes which are not there in 4G per se, and the SSC mode 1, mode 2, mode 3, all these modes are defined, but the problem is for the transport networks, there is no transport network awareness for some of the some of the SSTs. So this is, if it is a default bearer or voice bearer like LTE, it's not an issue, but different traffic characteristics are needed from the transport network. For example, low and deterministic latency or real-time mission critical or DBR characteristics that need to be fulfilled for some of the traffic SST types. Transport network need to be awareness need to be there. With the current approach, it is very difficult to provide SLA guarantees. So this is the one of the problem that is being addressed by this draft. And also there is a underspecified mapping function for 3GPP PDU session to the transport network planes, where different kind of PE technologies are possible in the underlay. So the proposed solution in the last IETF to here, this is the last IETF solution. So we introduced the concept of John from listening into the concept of mobile network context identifier, which which reflects the slice characteristics like isolation and the PE characteristics and slice characteristics mapped in the MTNC identifier. And this MTNC identifier need to be protected in the IPv6 packet, IP packet. It could be there are solutions that time is SRv6, or if it is an overlay solution, GDU can be used. And there are also other possible solutions are listed. We also received a comment from DMM working group that why don't we use the lower 64 bits of IPv6 address? And some of the comments from Peace working group is why don't you use the fast tickets kind of solution which is specific to IPv6. So all these comments we have taken care and we come up with the final approach. And the next slide, I think most of the solution that was put forth by John, my colleague, he will present the rest of that.
So before we go into this one question, right? So this mapping, it's not a new problem in that sense, right? Overlay to underlay mapping, it's not a new thing. It's not a new requirement. Right?
Yes, it was there, but for LTE early slicing solution 2016, for LTE also slicing solutions are deployed. They were using proprietary way of mapping things. But it's not a new problem. They were non-standardized way of mapping in early 2016 slicing solutions. We're just streamlining this approach with standardized approach.
Okay, thanks.
So I'll just continue and say what we changed in the solution this time. So as Uma mentioned, there were two different solutions in the previous version. And one of the suggestions was to come up with one. So we took the discrete and the integrated ones in the earlier one and have one single approach, a simple approach in this. And that's all in chapter 2 here. The second part of it was what required more work, I mean, under the section 2 here, carrying the transport context in the IP packet header. So we had a number of options earlier on, GUE and SRv6 and so on. I think it was Eric last time you mentioned about possibly encoding it in the lower 64 bits of the IP address. We've taken that and put into a solution where we look with the source, but we'll come to it on the.
So where do you get this transport context from? How do you?
Okay, so I can explain that. I mean, part of it. Oh, okay,
Yeah, we can take it off. That's fine. That's fine.
No, let's go to the next page. I'll explain. So here we have the 4 steps. I think the first step is partly 3GPP work, and we have specified. I mean, we have made clear that we mentioned that it's not IETF work to come up with this mapping. So somewhere, I mean, in 3GPP, there are these functions like NSSMF, the Network Slice Selection Management function, that is defined in the 28530, and they identify the 3GPP NFs, the network functions, and a transport network in between. So that's roughly what we've done. If you look on both ends, there are the network functions, the RAN and the UPF function, and a transport network in between. And the management plane manages to select the slice aspects for the functions, the 3GPP function and the transport network. I believe they've also selected ACTN in terms of managing that slice, but the details of it are still under work in 3GPP, I mean in SA5. So that's why we've put in here that the TNF is a logical function, and it's not something we're specifying. But the interface, the ACTN, is IETF. It's an IETF protocol, RFC 8453, which programs the IP backhaul. So the problem, in essence, going back to Sri's question, is that the 3GPP slice aspects, the NSSAI, the Network Slice Selection Assistance Information, is related to what a user is supplied with. And so the customer for the 3GPP network is the UE, and the customer for the transport network is the 3GPP provider. So somehow there's got to be a mapping between what was offered to the customer in the 3GPP domain versus what the transport network has to convey. Those are not the same. There is and it's not a one-to-one mapping. For example, there may be 1,000 customers and 3 slices, or slice instances, or in that order.
Mm-hmm.
So something has to be done, and that's what is being. I mean, that part of how they estimate and manage that mapping is in 3GPP, and we're not specifying that. We're just offering it as explanation. But assuming that has been done, and now that information is now programmed via the SMF to the RAN and the UPF, then whatever has been programmed in the IP network has got to be realized for every IP packet that transits that transport network. And that's what we're trying to do I mean, I think I've now explained those 4 steps.
So on the N4, what you're getting, the context is truly on the N4. Or what you're to the
N4
UPF.
and the N2, actually.
To the E node B, to the G node B.
And there is a sequence in that. All of that is what. So I think for the IETF side, the T's work would be related to the SDNC and ACTN. And here we can see that once the information is in the G node B and the UPF, the RAM function of the UPF, it's got to be conveyed in the IP packet so that whatever was promised can be provided by the transport.
And there's an implicit assumption that that context identifier is, the transport is aware of that, how to deal with that.
Right. I mean, we assume,
That's the assumption.
Yes. We assume that, actually that's a good question. We assume that it is not made per session. So the estimation or whatever, there are various functions in 3GPP that estimate over longer periods of time. And that's programmed in the transport network. So when a session comes, it doesn't try to go and figure out other resources and things like that. It's been allocated, and that only the mapping information is conveyed and realized.
Right. So maybe one elementary question, right? This is I'm trying to understand this. Not in a. So today, if you like DSCP and all of that, you do mapping at a session layer, right? So now we are dealing at a slice level. What are the pros and cons of what are the advantages of doing this way versus on the session level?
I think the DSCP method, I mean, is fine, except that if you go to the next page, I have, can I?
Yes.
Okay. So DSCP is not an immutable field. So as long as there is an agreement on how that operates, it's okay. Or if IETF comes up with whatever method. So that's one of the points. But even more than that, I think things like failure or isolation and aspects like that of a slice are not conveyed in DSCP. So that's one aspect. So we look through a number of alternatives just to see if we can use what exists, and even so, that's how we're coming to this. So if you go through it, there's the DSCP is not immutable. VLAN, I suppose it works in some scenarios where if you have the customer edge and the provider edge are in the same network, it's okay. It's not crossing a layer 3 boundary. Layer 3 VPNs also works in some scenarios, but not in many others where you have, it's very rigid provision.
L3 works or should work, but what?
I mean, we're thinking of cases with NFV and multiple. So it works under some scenarios, but it's harder to provision. I suppose it's possible. We can look at it.
Okay.
GTP header, the problem is that there may be a QFI in the downstream, but not on the upstream. And in any case, it's too deep for packet inspection. And so that's what we're looking at in terms of those.
Dave?
Yeah, I know who I am, so I won't say who I am for the minutes, but I'm Dave Allen. Just the interesting thing here is that source port is normally used as a source of entropy for ECMP. So I'm kind of wondering how either you're turning ECMP off or...
We are addressing that, Dave.
Okay.
In terms of,
so it's factored excels in the next section.
I'll keep my powder dry then.
No, I think that's a very good question. We got it from our authors as well, Praveen and others. So we're only using specific ranges, which allows for that entropy and make sure that there are no fat flows.
Okay.
And also, since it is GTP, we can use that. So we're not altering the source port of the user field.
Just a question, Chehatov. So that's interesting to when we see the PE router to be able to look up the UDP source port to handle which slice the packet bring it out. So which working group or standardization body working on the that PE router to be able to handle source port.
So I believe that it is in the IP header, and as a result, the parsing is nothing new. So we did not think of adding, but if there's something that needs to be done, we can look at it. The assumption was that it doesn't need extra work.
No, my question is, DMM is a place to start work on the standard for the mobility management in distribution manner, and Acton work on the traffic engineering, and you now propose the UDP source port as the ID to mapping the mobility session to the transport resource. So which area or working group to define that behavior?
There is no working group per se here. It's a local mapping function, and the PE nodes. How do you map the incoming session to this local policy-based routing, right? Today, do policy-based routing based on various packet fields. You map this information, incoming traffic to map to the tunnels. So what we are suggesting is this, it's not a new thing, putting in the UDP source code that is used for today for the, for example, what Dave is asking for load balancing. Sure. At both the ingress side and the RAN side are also on the UPF side, both sides. So we are latching onto this mechanism. We are extending one more indirection. But some of this extra indirection we created to encode this MTN's ID indirectly. So there's no working group. It's already working on working fields. So that's why this approach, we felt that it's backward compatible, even with existing 4G slicing solutions.
Suresh?
Yeah, Suresh Krishnan. So one of the things that concerns me here is, right, you're rewriting the UDP ports. Are you calculating the UDP checksum again? Or like, how does it actually work? Because unless you turn off the checksum, the packet is going to be dropped, right?
I think Uma is...
So the encoding happens at the G node P or the UPF. So we are not doing any additional stuff, which if you see that what is happening is it's operator control, this particular range of the UDP port, map it to this particular MTNC ID. So there's no rewriting. The first time when the GTP encapsulation happens, this mapping happens. So what happens in the PE router is only look up and map it to the particular TE tunnel. So there's no further rewrite.
Okay, makes sense. Like it wasn't clear because it looked like, it was happening somewhere in the wire there somewhere, right? Like between the PE and the G node B. So
I think we captured the point about the entropy, but we've got to capture this part.
Okay.
That it is
Thanks.
not rewritten.
Okay, thanks.
Okay.
This is Xue Song, and I think the VLAN ID should not be excluded in this solution because in the first hop from the run to the PE node, the VLAN can represent the network slice information, and in the IP domain, we can use other network slice encapsulation to respect the information. So I think VLAN ID is a reasonable solution too. So
we can include that. I think we'll mention it with some constraints. So the VLAN ID, as we mentioned here, if it doesn't cross the layer 3 boundary, it works. So if you have the customer edge and the provider edge to be the same domain, then it's okay.
But please state your name, please, for the note. Please,
sorry?
Please state your name.
Yeah, I will. Offline, I will. Sure.
So we'll make a note of that.
Marco Lieb, just for correct understanding. So since GDP is a bidirectional thing, so both endpoints of the GDP tunnel have to use the same transport network identifier in the source port, or can they be different? Can you have multiple of these identifiers to unambitiously identify the slice that the traffic is associated with?
I don't think the solution imposes that necessarily, but it could be that. It's something that, again, we can add and clarify.
I think it's an important aspect because for implementation, you may have multiple IP endpoints to represent the GDP between two same nodes, right, for load balancing or whatever.
So to be clear, I mean, we are considering that as unidirectional flows. So how we handle that is handled at each point, the translation. So usually I would assume that there's some symmetry, but you're saying that if there is some asymmetry, That should not be a problem in this case.
Is there any reason to not use identifiers which are part of the GDPU header?
So, for example, if we're using a range, 10 to 20 on the upstream, we don't necessarily have to use 10 to 20 on the downstream. As long as that translation is mapped in the nodes to mean the same thing. And they are unidirectional.
And the advantage of using this identifier instead of using, for example, the TIDs in the GDP is to have less keys to look up for the transport network, right?
I suppose the TIDs don't give the information on QoS. We could get some QoS information from the QFI, but then even that's not enough if we're considering the slicing requirements that 3GPP has defined.
But TID maps to bearer, right? You do get the information, right?
Yes, but it's only available to the 3GPP node, the transport node.
Transport has no awareness.
All right.
Hi, Takayama Yasuko from KDDI. So, for the UDP source port, how does GNodeB know the source UDP node? Are you going to use existing N2 or N4 interface with some kind of extension?
So the N2 will only program the NSSAI because that's what 3GPP knows. The range of the source of the UDP port should be handled by the IP network in terms of how to, as Dave asked about the question about how to handle entropy and how to make sure that there are no fat flows.
So you don't use existing 3GPP control operating function like PSGP?
No, I think 3GPP won't know about these things. And better not to take it.
Okay, thank you.
Okay. So I think we covered pretty much all of that.
Yeah, great discussion. Any other comments, questions? So yeah, this is looks very interesting, but I think there are many questions, comments. I suggest you guys keep doing more work, and at some point yeah. Any other? Suresh, you have any comments on this? Okay. All right. Yeah. Again, good stuff. Yeah. Thanks. Yeah.
So on the adoption, do we wait or ask from the group?
So you're asking us to issue an adoption call now?
It's the question that we want to ask.
So I think maybe before that, let's ask how many people read the document. Can you guys? 1, 2, 3, 4. We need a little bit more than that. Okay. So I think maybe we can ask the working group to review this, and then we can issue an adoption call.
Could you help us with that?
Sure. But I think you guys want to engage a little bit more the working group, and I know. Carlos, Suresh, yeah.
I have one more comment. I think the last part of the work, the how to map in the user plan from the run to the IP backhaul. I think this is whether this part of work can be separated from the current draft. I think this is some isolated work, and this is very important for the network slicing mapping relationship in the data plan. This is just a suggestion.
So why are you? I'm just curious on that. So you want that to be taken up in a separate document and different working group, or what's your recommendation?
Yeah, in the same working group. But I just think this part of work is not so relevant to the rest part of the. I think it's not connected very strictly together. They just different work. They are all important, but they can be existed in different drafts.
Okay.
That's my suggestion.
Just to understand, which part are you specifically saying?
Just the user plan mapping relationship. Just some solutions you listed in the previous slides, which I comment.
Okay.
Yeah, that part of
we'll
work.
add the point about the VLAN, which is what.
Yes.
Hi, Carlos Fernandez again. I can also take a look and provide a review to that document.
Okay.
Thank you.
Okay, Carlos, thank you. So yeah.
Question. Which track do you prefer, informational or standard track?
I think we're not defining new standards per se. So we marked it as informational, but I'm not an expert on this.
Okay. Okay. Yeah. Let's make sure there's more discussion, and I think there's good feedback. But yeah. Thanks.
Thank you.
Thanks. Next one is architectural discussions on SRv6 mobile user plane from Mia Singh. It doesn't work, but you can try.
Today I'd like to talk about architectural discussion on SRv6 mobile user plane. My name is Mia, and I'm presenting on behalf of the co-authors. So today I'd like to talk about motivation, goal, and architectural discussion, and some exemplification and next step.
Oh.
So the direct motivation is pretty much similar to the previous presentation, how to map the mobility data plane to the IP. I'd like to address a kind of meta level. So system architecture needs to be reviewed holistically and across layers when drastic architectural transition is required. For example, in the 5G era, where various SLAs are to be supported, and where completely new data-intensive services like analytic IoT distributed computing are assumed. This document discusses the architectural implication of applying the SRv6 mobile user plane, not necessarily SRv6, but especially regarding the possible optimization of existing conventional layers. Hence, we hope it suggests that SRv6 mobile user plane is the right architectural choice for the 5G era. So, mobile network and transport network are separated by layers. TN, which is 3GPP technology, transport network, is an underlay layer to the mobility network. And GTPU is an overlay tunnel in the mobility network. Layers solve any problem, but each layer evolves independently in order to solve any problems, which could result in overall inefficiency, like famous saying by David Piras indicated. So let's take an example of network slicing, end-to-end network slicing. So in the typical GTPU over IP MPLS configuration, a 2GPP data plane entity, such as UPF, is a CE to the transport network's PE, or even needed extra CEs, like Shunsuke, which in the work of the user plane protocol analysis in this working group, nicely explained the problem. So with the current practice, since mobility network and transport network is separated, which complicates the architecture. So as we discussed in the previous presentation, a certain extra ID, such as VLAN ID or NCT ID, that kind of extra ID is needed for segregating traffic and mapping onto a designated slice in the same link. And also, P and PE-CE connection is a single point of failure. So some form of PE redundancy using routing protocol or NCLAN kind of things are required, which complicates the architecture.
Please try. そう。これやって進めます。戻ります。
And if we move the border, then we can simplify the architecture much. And now that CAPS, a control plane user plane separation, is a mainstream for 5G practice, And user plane entities are dedicated to forwarding. So in that case, it is reasonable to have 3GPP data plane entities like UPF be part of transport network. And this is the 3GPP document, and it says the control plane and user plane is separated. And if we move to the border, the merit of this model is there's no need for PEC hierarchy. There's no need for extra ID for traffic mapping, and we can directly control the underlying SLAs. And from the perspective of implementation, someone says it's unrealistic since the GPP entity that don't care of IP routing. But I would say it's realistic and even it's more rational in the new generation. Since 5G use cases rely on flexibility of cloud native. And in the cloud native service mesh deployment, sidecar proxy on the same server machine or the same container port would take care of the communication like routing and forwarding or such kind of things. So that service can be service or applications doesn't have to understand the routing semantics. And some may say that the administrative domain is separated, and they may not want to expose the topology. But in that case, SR segment routing binding seed can be used if topology needs to be hidden. And for edge computing, SRv6 flexible traffic steering capabilities and the network programming concept for freely describing instructions and metadata are per se suitable for providing edge and distributed computing. In addition, since SRv6 can be a common data plane, regardless of the domain, such as access, wide area, mobility, or data center, service placement and service chain that used to be concentrated in data center historically can be expanded over a wide area, which is good for edge computing. And with SRv6, session and QoS information can be exposed in the IP header, which does not affect performance thanks to the longest match mechanism in the IP routing. So only the services or applications who need that information for granular processing are to look up that kind of information. So this would allow flexible placement of service applications. And for URLLC, ultra reliable low latency communications, 3GPP TR2375 investigates the key issues for meeting the URLC requirements on latency, jitter, reliability in the 5G system. However, the solution provided in such document are focused at improving the overlay protocol and limit to provide a few hints into how to map such tight SLA into the transport network. And these hints are based on the static configuration or static mapping for steering the overlay packet into the right transport SLA. And such solutions do not scale and hinder network economics. And that document, section 6.4, addresses the issues on how to support redundant data transmission via single UPF and single LAN node. But how to ensure that this joint path is not enough in the document. It just says using different IP address or different network instances, but it's not assured that the path is disjoint. Further, 3GPP data plane entities need to support packet duplication and elimination. This actually requires the modification of GTPU protocol itself. So it it need to evolve GPU independently, but I would say it's not good. It's too much. The SRv6 mobile user plane also has an advantage in this respect, thanks to the net programming capability.
You need some water?
Sorry,
Okay.
yeah, it's okay. No, last slide. So next step. It's a kind of meta discussion. So I hope you could join this kind of discussion, and comment discussion are welcome. And I hope that DMN working group adopt this document. Thank you very much.
Thank you, Mia. Questions, comments? John?
Thank you. Good points on the URLLC and the complicated network there. Just a question, how does SRv6 allow the paths to be disjoint? Can you elaborate on that a bit?
Yeah. SRv6 can provide live path protection mechanism passive, and also it could provide the TI-LFA, which assure the sub 50 millisecond convergence. And the point is that the SR-aware entities can directly control that kind of mechanism, not different layers. Which
maybe
could avoid the single point of failure of duplication or the elimination.
Maybe the question, I didn't put it pretty clearly. I mean, if we have the path between the G-Node B and IUPF and PSA UPF, and there are two of them, how do we make sure that these paths are disjoint using SRv6? Maybe it's a detailed question, and
It's the beauty of SRv6 passive.
Okay.
Maybe John, we can hire offline or because that's an involved topic, right? Maybe I suggest, I think, maybe you want to sit. Yeah. Okay. Thanks. Suresh?
Yeah, Suresh Krishnan. So one question, Kono-san, this is, I understand why you're doing this, right? I'm trying to understand why it's a separate document. So why is it not something that's folded into the Satoru-san's document or Homa-san's document as either in the analysis side or on the solution to say why this is better? So I'm just trying to understand why you think a separate document is better.
Well, the mobile user SRv6 mobile user plane document simply describe the protocol.
Yep.
And the Shunsuke or Homa-san's document provides the analysis, which are good. I wanted to discuss more about the architecture implication, but if I'm open to join other works.
Okay, I think the text itself is useful. I'm not sure about the form of how it needs to go. So I think it's probably worth discussing how it actually proceeds. Okay, because as you know, right, a lot of the times, when we have a document like this, which has it's pretty dependent on other stuff, right? So the question is, why should it be a separate document, right? And this is something that comes up in the IESG. I told Sri, right, we have an IESG statement, right, on what is called support documents. So I would really like the working group to think about it, and if the working group decides it needs to be separate, that's fine, but I just want to put it up there so you think about why it needs to be separate and put it in the write-up why it is separate. Okay, thanks.
Absolutely. I think great points. I think I'll just chime in there, right? I think you brought out a number of good points there. I think, but Suresh's question is very fundamental to this in the sense that there's already two documents, right? Now, if you can fold some things there, it's great. But if you still have some good stuff, which may, if you can justify that, we need to have one document which, covers the overall thing. If you can justify that, we can, I think that can be done. But again, yeah, it's good stuff in there, but let's get the feedback from us here.
Okay, my name is Uma of Future USA. So I read this document. She's raising very interesting overall big question to the community, actually, she's asking. I think now I understand better the second presentation because it has this direct connection, right? Like you can collapse GTPU and SRv6 and you can have much more transport benefits you can get. It's all good, but the only question I have is, so we are seeking it's kind of envisioning in future only IPv6 based transport, right? So what happens to the backward compatibility, these kind of things? I think this way 3GPP is stuck with GTP, right? Like when the discussion started, they were only using an S1U, they moved to N9 now, and they moved GTPU to F1U. So they are expanding GTP usage while we are discussing, how to give them much more transport benefits, right? So there's some tussle going on there. So I think it's a good document. I think you laid out the points what SRv6 can bring it to the network, but it's a much more bigger discussion actually.
Okay. Hannu Flink from Nokia. In the slides you mentioned service mesh, and I wonder what that has to do with slicing. I think it's more for the control plane entities in 3GPP, and it's an implementation matter. So.
Yeah, it's an implementation matter. You're right, but it's a kind of cloud native practice, implementation practice. So the conventional thinking, box thinking, need to be evaluated. That's my message.
Okay, but what is the role of SRv6 with this service mesh or the proxies?
Well, so
I think we are talking about different layer.
Yeah, argument could be that the 3GPP entities like UPF doesn't know routing, doesn't know SRv6. That kind of argument could happen. But I would say that if there could be a kind of proxy or sidecar which can do the all routing, forwarding stuff, like our routing on the host implementation. So the application doesn't know the routing, but the routing sits in the host. In that case, we can provide the routing capability from the host.
Okay.
I just want to respond to the same things, Rajiv, Cisco. So I think I actually really like that analogy of sidecar related to this specific content in the draft, because the sidecar, this whole notion is to allow for the proxy to sit adjacent to the application themselves. So if you think about these different network functions, these different functions related to the RAN or then the 5GC side, these functions are now capable of hosting where they're sitting, which are host. Now they can have these routing, the forwarding nodes next to them, just like what the Envoy or the proxies do. So the notion of having them adjacent to each other clearly has tons of benefits as proven in the cloud scale. So thank you for actually including that.
Just a quick comment. Sidecars are functioning at the HTTP level, not SRv6, which is quite below in the protocol stack. So I'm on the opinion that we are mixing things now very badly. There is application level routing, HTTP level request routing. That's the business of sidecar. And then we have this SRv6, which is on IP level, or maybe even below.
Right. Indeed. So there's also the notion of application routing. So with HTTP, then there's a network services mesh, which is at IP. So I think that those lines have been blurring for quite some time.
Okay, Suresh.
Yeah, Suresh Krishnan. Just like closing off on this, Hannu, right? Like, so the way I understood it is, right, like, the sidecar pattern as a design pattern allows for the application to be unaware of what's happening underneath, right? So as you said, it's right now used for HTTP, like certificate, like offload and things like that for the security. But I think Kono-san's point was like, if your SRv6 is like put in a sidecar pattern, then your application doesn't need to know about it. So you can take your VNF today inside a VM and you can containerize it, and that can take SRv6 assets and use it. I think that's kind of our thinking. That's how I understood it.
Okay. Any other final questions, comments? Okay, thank you, Mia. I think, yeah, this is again good work, a lot of good stuff in there, like the previous document, right? I think we need more discussions and we'll take it from there.
I think the last comment is this presentation 2 and this presentation are very much connected, actually, what you guys are trying to do.
Right. Right. Is there, so one other document, this is more on a maintenance track. This is from mobility capability negotiation protocols. Okay.
Hello
Siri?
everyone. This is Julian, and actually the other authors of this draft is Anthony from Huawei. And,
just 1 second. Where are the the blue sheets? Sorry. Thank you. Too much of alcohol last night. Blue sheets, please. Okay. Did everybody sign the blue sheets? Okay. Let's continue. Sorry.
okay. And is the microphone on? But I'm not sure if no, you can hear really well. Not just you can listen to clearly. It's not on. Okay, I will be louder.
No, turn it on. Is it on?
Also, maybe no power. It's okay. Thank you. And the other authors of this draft is Anthony from Huawei and Li Jinghe. And actually, I guess Anthony has presented this draft last time, and we did a lot of extensions and polish it a lot. And now I will introduce it here, please.
You can use this. Try this. Oh, what is the logic?
And we all know that the IETF and other organizations has standardized many mobility management protocols, and we can put them into 2 categories: the network-based solutions and the host-based solutions. And in the network-based solutions, the main protocols are the PMIP-based protocols and their extensions. And similarly, for the host-based protocols, and mainly based on the mobile IPv6 and some extensions. So a question here is that, sorry, it cannot work. Okay, and when the mobile node access to the network, maybe the first time access or the handover, what kind of mobility management protocol can be used? And because the network may support some protocols and the host may support some protocols, and maybe the host prefers something and different from the capability of the network. So this draft mainly research on this problem and to support the negotiation of the mobility capability between the host and the network. Next, please. So we may have some basic principles here. Is that the first one is to during the negotiation we need to follow the network ability, and the second is follow the host preference, and third is support the functional extensions, and the fourth one is to support the performance enhancements, for example some fast handover or something like that. And in default, in order to guarantee the performance of the mobility management, the network-based schemes can be should be used if it can be supported. So after the initial attachment of the mobile node, a profile will be generated in the management store to record the selected or preferred protocol of this host. And when the handover happens, the network will check the selected or preferred protocol, but the network also needs to notify the host if the selected protocol cannot be supported in the new area. Next, please. And we have some examples in the draft, and I list one example here is that a host and network both support the network-based protocols. And for example, when the host supports the basic proxy mobile IPv6 and the network supports some extensions of the based on the proxy mobile IPv6, then if the extension protocol mobile IPv6 has no requirement for the mobile node involvement, it can be used. And otherwise, the basic proxy mobile IPv6 should be used. And the second case is that when the network and the host both support some extension protocols, and if the extensions are same, it can be used. Otherwise, the basic proxy mobile IPv6 can be selected. And then we need some solutions here is that the signaling message should be exchanged between the host and the network to exchange this preference and the ability. And maybe based on the extension of the ICMPv6 or some authentication messages. And another problem we need to consider is who will initiate this negotiation, the host or the network.
Suresh.
Are you done with the presentation or?
There is a last. And we give out the possible solution is based on the ICMPv6 is a new option. Here is proposed, namely mobility capability, MC option, with a corresponding flag in the ISRN message. When the mobile node and the network exchange the ISRN message, the preference and the supported protocols can be included in this option, and then the protocol can be selected finally. Yeah.
Okay, Suresh Krishnan, as like responsibility here, right? So one of the things is that like everything you say has been tried before in the IETF, multiple times. So if you go back to like 2007, 2008, the NetLMM MNAR interface is exactly this, okay? Except that it never worked because like a network usually decides. If the network decides it's going to do some kind of mobility, it's going to do it, right? So it's not going to negotiate with the host why it's going to do it. That's kind of something we found out like as a result, right? It's not that we didn't try. So there's been multiple iterations of this. I know there's one like Raj and I did for like, CMIP versus PMIP is something we've tried. Like Sri did some prefix coloring stuff. So there's been like multiple failed attempts at this, right? Mainly because of not technical reasons. Okay. So there's like, it doesn't fit any deployment scenario where like, so I'm positing that there's no deployment scenario where this would be useful, right? Because of if you take the architectures, none of them are made to allow this. Okay. So if you can figure out like, where you would use this, like, who are the people interested in this, I think we can pursue this. But otherwise, like we know there's like a lot of past history of failures in this thing because the incentives are not aligned for people to do this. Okay. So think about it, how you would apply this, where you would apply this. I think that could be very useful input for the group to decide if it's useful. Okay.
Yeah, thanks, Suresh. I think that's a great input. I think MNAR interface document that was Julian published it. And see, I think the network to endpoint interface was one thing we truly missed. We don't have it actually, even today, right? In any of this, right? Having a standardized interface makes sense, but we could not. Somehow we always fail. We tried, but we failed. So I think the question is, we need to see, we need to look at the previous work and see what we can do now. Did the situation change? Can we push it now? I do not know. I don't have an answer, but this was tried before. Yeah, please continue. Yeah. Last slide or? Yeah.
No.
Oh, okay. Okay. So I think my suggestion is, I think, you may want to, work with few people, get some more feedback and see if it has potential, then invest time on this. Otherwise, you may want to think whether it makes sense or not. Okay, any other questions, comments? All right, thank you so much. Next is Sato-san will give an update on, Rajiv.
Just one quick one, minor one, Rajiv, Cisco. So if you think from the endpoint being attached to cellular, then I presume this message would go from potentially the endpoint towards the UPF or the SI gateway. In case of the mobility happening between cellular and say Wi-Fi, then this message is assumed to be going from the endpoint to where?
It's the same thing, access router.
Right, so they may be two distinct, right? Access router, or in case of EPDG, it might be the same thing as a SI gateway, one upstairs. But then there are a number of possibilities. So this notion of having something in the RS, an array, would mean to allow for the mobility to work, have to be compatible not just within the cellular realm, but outside as well, potentially. Something to think about. Though I do like the fact that this is an RS array, so it's a really low-hanging, small footprint in terms of protocol extension, and thankfully doesn't require anything to be done in the mobility protocol. So that's one different thing I see from the past, Suresh.
Actually, this one was RS array based to the other ones as well.
Ah.
Okay.
Suma. So why, Suresh, sorry, I don't have the background on this. Why you said it's failed? Because it's a security issue, union interface. It's always problematic, right? User to network interface. Is it security is the main thing, or?
Yeah, I want to hear the answer.
No, it's I really think this thing was not anchored in architectures anywhere. So somebody used to say, some wise people used to say in the IETF, we do protocols here, not architectures, right? So for good or bad, the architectures are done somewhere else, right? So unless you go and anchor this the other places where I think I know Sri has the same scars, right? So we had to go to 3GPP, go to 3GPP2, and everywhere to make sure that our stuff is anchored there, right? Because without that happening, these things are not going anywhere, right? So that's kind of the part that's really missing, is really the deployment support for this thing. So security is one thing, we can fix it. So if you look at the Julian and Pete's draft, right, which is the MNAR interface, everything Rajiv said was actually looked at. We spent a couple of years on it, address everything, except that it was not deployed, right? So I think it's mainly a deployment issue. The incentives were not right to do this. So nobody was really interested. For example, right, Qualcomm was doing the chip and they didn't care about the network-based mobility, right? And the operators didn't want to have the UEs to have the mobility themselves. So the incentives really were not aligned very well.
I can. Okay. Thank you so much. Yeah.
Okay.
So yeah. Okay. Next is an update on FPC. So this I think just a lot of work went into this, but lately the document has expired, and I think we thought the work was done, but it never cleared last call. Yeah.
Yes. Thank you. This is Satoru speaking. I try to describe the little bit background of the FPC work with the Kosa, Marco, Danny, Lyle, and Suri. So the work had been started at I remember that around the 2030, and then first document submitted to DMM working group on 2014, I think. So the DMM working group adopts that document as a working group document. So we work a lot to update the document spec based on our discussion how to configure the forwarding policy for the user plane or data plane node. So as a result of our discussion, the FPC did not touch any, over the wire protocol. So instead of that, we defined API to configure the user plane from the application. So that's the reason we decide to define the Yang model to provide the API. So after the discussion of around the 2016, after the Buenos Aires meeting,
So we decided to change the data model and the information model to divide to the topology and mobility and policy. Those three model conjunction to derive the actual forwarding policy configuration to the data plane node. So after the 04 revision, we take that model and FPC document describe the information model of that, and data model by Yang follow that information model. So after that decision, we make bunch of the revision. Maybe yes, we have a revision 12. I think it's be mature and live from sprint. Take a lot of the work to edit the document, and the Charlie volunteer to divide the Yang model from the main document to make the document short, because the whole of the document becoming over the 100 page, so it makes the reviewer be really difficult to make right comment and to decide whether it will be good or not. So that's the latest status of the FPC work. After the last update of the Yang model by Charlie, there's no update happen. So then the both of the information model document and Yang model document is expired. That's the latest status of the FPC. So the reason why I share the background of the FPC work after the long silence of the last update, so I would be happy to discuss whether we proceed or not the FPC work in the DMM working group with you guys. I think there are many people put the much effort to this work at the beginning of the discussion of the control plane, user plane, or data plane separation. So I think it will be a good outcome here, but it depends on the interest of the industry or community for the mobility area. I'd like to hear your comment. Please.
Any comments? That explains the interest.
Let's start with comments. So I'll make the first one. So I'm co-author, and I know that the work that we put into this, though it has been revised in details quite a lot, but it's pretty mature as well, pretty stable since a while. It's as stable as drafts have been expired. So I think there was a plan how to further progress the reviews on these two documents now. There was one document which was version 12, then we split it, right? And I think only the Yang part has been published so far. And as you said, your opinion is that it's pretty mature. So since we have two pretty mature parts, I think what we still need to do is the review parts. But in my opinion, we should progress these two drafts towards RFC. Of course, we need reasonable reviews and comments for Manicure, but I also think it's reasonable work and a lot of work has been put into it, so it would be a pity to not progress these drafts.
Okay, thank you, Marco. That's one opinion and an author. Any other comments? Okay, so I think we will confirm the same in the mailing list. If there's sufficient interest, we'll move forward with the application process or complete the last call process. But we definitely, I do think the document is in a great shape, but still, we need to go through the process. We need reviews. I think it's not just the author's view, right? I think the working group has to say that. I think that hasn't been established. If that happens, we'll move it forward. Otherwise, we'll kill it. Suresh, is that a reasonable option? Yeah. All right. With that, thank you so much. And did everybody sign the blue sheets? If not, please sign the sheets. Thank you so much. The meeting is now closed. I don't know. I don't understand this. This is bizarre thing. But slides are mere slides are good thinking. A lot of work went in. I can see you all over.
Yes. You truly understand the concept of this.
Very good. Very good. Very good. Very good. Impressive. Dave, thanks for taking the notes. We have to do those.